Hello guys, today we are going to study about the Wavy method. This is one of the easiest and most efficient ways to solve quadratic inequalities. This method is used in various concepts that you will study in your later mathematics, such as first derivative test or calculating just basic inequalities to calculate intervals that you will find your answers in. This method is suitable both for board exams and for your JEE and NEET exams. So, let's start with a problem. Suppose you have a question. Example: x minus 1 times x minus 3 greater than 0. If you would have solved this question earlier, you would have done this like in two cases. Case 1. Suppose we take this example: x minus 1 times x minus 3 greater than 0. Solve for x. So we have to find the interval in which x lies here. So in your earlier classes, you would have been studied that x, for example, case 1, x greater than 1 and x greater than 3. Therefore, we take a number that is greater than both 1 and 3, that is 4. Let x equal to 4. Now 4 minus 1 times 4 minus 3 equals 3, that is greater than 0. And case 2, x equal to minus 1, because it is both lesser than minus 1 and minus 3. Minus 1 times minus 1 minus 3 equals 8, that is also greater than 0. We can see that if we take one bracket positive and another bracket negative, then we will get an answer that is negative. So it will never be greater than 0. So these are the only two possible cases. Now we plot this on a number line for case 1. First number line, 1 and 3. These two are known as the critical points because these will be the two possible solutions of x if we put an equals to sign instead of a greater than sign. Now we have taken here that x is first greater than 1, so we can proceed this region as x greater than 1, and x is also greater than 3, so we can all take this region as x greater than 3. Now for the final answer, we will see that we will calculate the common part of both these number lines, that is 3 to infinity. So the interval here will come as x belongs to 3 comma infinity, and we can see here that it also gives the answer x belongs to 3 comma infinity, because it will take all the numbers that are greater than 3 till infinity. For the second case, we will similarly draw a number line as 1, 3. In the second case, we will see that x minus 1 is lesser than 0 and x minus 3 is lesser than 0. So therefore, the number line will be as, and for the final answer, once again we have to take the common part of both these lines, that is, therefore it gives us that x belongs to minus infinity comma 1. We can also here see that x belongs to minus infinity comma 1. So we can show that the final answer is x will belong to minus infinity comma 1 union 3 comma infinity. This union symbol means that a final answer will contain both these values that are between minus infinity and 1 and 3 comma infinity. We can also write this as x belongs to all real numbers except 1 comma 3. This means that the answer will not contain any real value that is between 1 and 3, that is, for example, 1.5 to 2.5 etc. Now you would have seen that it took us a lot of time to solve such a simple problem. The Wavy method gives us a method to eliminate all the bigger steps and solve it in a second or two. So for applying the Wavy method, if we take the same question, x minus 1 times x minus 3 greater than 0. Now, in the Wavy method, you first have to find the two critical points of the quadratic equation. Here, the two critical points are 1 comma 3. Basically, the critical points are the solutions that you would have found out if we would have equated the equation as x minus 1 times x minus 3 equal to 0. So We start out by pointing the two critical points on a number line 1, 3, and here is plus infinity and minus infinity. Before knowing about the Wavy curve method, we should know about a few basic points about it. First, for an odd power, the sign will change. For example, if you have a power of x minus 1 cube times x minus 3, then the sign will change on the x equal to 1 critical point. Or if we had an even power, for example, x minus 1 square times x minus 3, then the sign will not change at the x equals to 1 critical point. Second point, if we have the greater than inequality, then the answers we will be taking from the number line will be those who will have the positive sign. And if we have the lesser than inequality, the answers will be of the negative sign. And the most important point is the intervals will always start with the positive sign. So, coming back to this number line now, we have marked the two critical points 1 and 3. Now, we knew that there is a greater than sign here. So, first of all, we will start the intervals with a positive sign. Now, as you can see, there is an odd power that is of x minus 1 times 1 into x minus 3 power 1. So, the sign will change, that is, the positive sign will go to the negative sign. And now again, we can see that x minus 1 has an odd power, therefore sign will once again change to become positive. Now, the answer we will get here is x belongs to minus infinity comma 1 union 3 comma infinity. And you could verify we got the same answer with the long method. Another example, x minus 1 square times x minus 5 lesser than 0. Now, once again we have two critical points, x equal to 1 and x equals to 5. We mark both of these on the number line. We first off start a number line with a positive sign. Now, we can see that at the x equal to 5 critical point, there is an odd power, which means that the sign will change. So, the sign will become negative here. And now, at the x equal to 1 critical point, you can see that we have an even power, which means that the sign will not change, or it will remain negative here also. Now, you would have seen that there is only a lesser than sign here. There is no lesser than equal to sign here. So, we will get an open interval. The open interval means that in the answer we get, we cannot write the values x equals to 1 and x equals to 5. We can only write x lesser than 1 or x lesser than 5. So, the final answer we will get is x belongs to minus infinity comma 1 union 1 comma 5. You must be thinking why we have not combined both of these. This is because, as I told you earlier, it is an open interval here, which means that you will not write 1 or 5 as your answer. If there would have been closed interval, which would have been specified by writing an equals to sign below the lesser than sign. Let's try one more example. X plus 2 whole square times x minus 3 raised to the power 5 times x minus 7 raised to the power 3 times x minus 10 lesser than 0. Now again plotting all these critical points on the number line. Minus 2, 3, 7, 10, plus infinity, minus infinity. Now, we all know that we will first start with the plus sign. Now, at the x equals to 10 critical point, we will see that we have an odd power, which means the sign will change. At the x equals to 7 critical point, we again see that we have an odd power, which means that the sign will change once again. At the x equals to 3 critical point, we again have an odd power, so the sign will change once again. And now, at the x equals to minus 2 critical point, we have an even power, which means that the sign here will not change. So, the final answer here will be x belongs to, here we have the lesser than sign, so we will take the negative values for the answer. So, x here belongs to minus infinity comma minus 2 union minus 2 comma 3 union 7 comma 10. Again, we have not combined both these steps as we know that we do not have an equals to sign here. So, both x equals to minus 2 and x equal to 3 are open points. So, they cannot be in our answer. We will be studying more about the Wavy curve method in the upcoming video. Thank you.